Welcome to qnawire.
Chapter 21, question 6, asks us to determine how many moles of silver chloride will precipitate out, given that there are 4 complexes with the same oxidation state, 1 mole each in water with H2O and Cl minus ligands and counterions. These complexes are all octahedral. And we have to figure out, the first thing that we actually have to figure out is the 4 complexes that are going to be in solution. So to determine this, first we need to determine what oxidation state these 4 complexes are going to be in. And the easiest way to figure this out, so they're all chromium complexes, and the first complex that we can think about is, that's a 2, is actually this complex right here. So it has 3 ligands that are water, 3 ligands that are Cl minus, and chromium has a 3+ oxidation state with an overall charge of this complex being 0. So we have to keep this chromium at the 3+ oxidation state. The actual overall charge of these complexes doesn't matter for this question. So the second complex that we can think about, we can actually replace one of the Cl minuses with a water ligand. And what this does is it keeps the chromium at the same oxidation state. However, there is now a +1 overall charge, and therefore you need a Cl minus to act as a counterion. Now we're just going to repeat this trend 2 more times. So you now have 5 ligands that are water and 2 Cl minus that are counterions. And the final one would be H2, 6 ligands of water. This obviously has a 3+ overall charge, and therefore you need 3 Cl minuses to act as the counterions. So now that we know the 4 complexes that all have the same oxidation state for the chromium metal ion, we have to determine how many moles of silver chloride are going to precipitate out if you add excess silver nitrate. So 1 mole of silver nitrate will react with 1 Cl minus counterion. They won't react with the actual ligands bound to the metal, but they will react with these counterions. So, knowing this, we have an excess of the silver nitrate. This 4th complex right here has 3 Cl minus counterions, and therefore this is going to generate 3 moles of this silver chloride. We can then do this with complex 3 right here, which will generate 2 moles, 1 mole for complex 2, and obviously 0 moles for this first complex. So adding these all up, we get a total of 6 moles of silver chloride that are going to precipitate out if we add excess silver nitrate to 4 different chromium complexes that have the same oxidation state and are octahedral.